This video presents a dual-arm robotic system that exploits tactile feedback to perform coordinate in-hand manipulation for an assembly task, while controlling the internal forces. The robots lift and transport the building block without knowing its weight. The relative pose has been intentionally perturbed to enhance the effect on the internal forces during the manipulation, thus showing the effectiveness of the proposed control strategy. In this experiment, the internal force control is turned off. Thus, calibration and synchronization errors yield large internal forces on the object. The grasp controller enables a pivoting action around the grasp axis. This permits an easy reorientation of the object, with no regrasping and no robot reconfiguration. The same experiment has been repeated with the internal force control activated. From the plot, it is possible to appreciate a significant reduction of the internal forces. The internal force regulation causes a slight deviation of the object's absolute trajectory due to neglected compliance of the soft contact on the UI robot. In fact, the block is not perfectly horizontal. To recover the placing accuracy in the assembly task, the internal force controller is switched off just before the placing phase, with the intention to highlight the effects of the contact compliance, which requires an additional control action. Of course, after the deactivation, the internal forces increase again. The assembly task continues with the other blocks. The robots exploit the in-hand manipulation capabilities to reorient the blocks. The augmented redundancy allows completing the assembly task within the workspace limits. To place this block, the additional redundancy is exploited to configure the UI arm so as to avoid collision of the gripper with the previous block. Here, after deactivating the internal force controller, the small corrective displacement is visible again, and the object is brought to the exact absolute pose. The placing of the last block shows that the in-hand manipulation capabilities are exploited also with a pivoting in the horizontal plane, keeping the robots within the joint limits.